I'm really excited to introduce Joel Boerckel for this workshop because we asked him to be our expert because really the main idea, as Shweta said, is to kind of get a little bit more experience and some hands-on how to prepare effective scientific presentations.
Claudia, thank you so much. That was a really kind introduction. I feel very touched. Okay, so let me share my screen and go to my presentation. Okay, so I've called this "How Not to Give a Talk," I'm really excited to be able to give this presentation today because has this idea of presenting your data, right? That you've worked so hard on has become something that I really enjoy thinking about and I care about. So what I'd like to do today is share some thoughts on how do you put data together, and then how do you present it in an effective way. So if you want, you can put my little face down here at the bottom right, and I'll try to keep all of my slides from covering that up. So I'm excited about this topic in part because I used to be really bad at this. And when I started graduate school, I really had very little experience with giving presentations. And then I remember my very first conference talk as a graduate student. It was so bad. I was shaking uncontrollably. I could not hold the little laser pointer still. And really, this is a topic that anybody can do great. You can absolutely do amazing at this. Okay, so this is a really fun topic, but also a really important one because as you progress through your career in science, this is going to be more and more of what you do. Okay, so let's think about how we give a talk. To begin, I want to tell a story about somebody who is a sort of a personal hero of mine. This guy, Edward Alfred Martel, he was a famous cave explorer, and people call him the father of modern speleology, which is the study of caves. And he was famous in part because he developed this new method for mapping caves, which is this technique called the coupe. It's basically like what we do for histology sectioning. You take a cross section of in this case, the cave, and you can see its internal structure. But what I love about Martel even more is the way that he talks about the adventures that he had and the way that he describes it. So this picture on the right here is a cave in Southwest France that he was the first one to explore. And this quote that I have here, and I'm going to read it to you, are the words that he had after he finished exploration of this cave in 1889. But as I read this, I want you to think about what it's how this plays with the practice of being a scientist. Okay, so I really think there's a lot of really wonderful connections between being a cave explorer and being a scientist. So he says this: the unknown draws us irresistibly forward. No one has gone before us in these depths. No one knows where we go nor what we see. Nothing so strangely beautiful was ever presented to us. And spontaneously we ask each other the same question: are we not dreaming? Right? And there's this sublimity to discovering something that nobody has ever seen before. And I think we get to experience this as scientists, right? All of us get to, at times of our lives, see something that nobody in the world has ever seen. And that's unbelievable. It's amazing, right? At the same time, the practice of being a scientist doesn't really look like this. It looks more like this, right? We spend almost all of our time in the dark, stumbling around. We stub our toes. We hit our heads. We have no idea what we're doing, what the techniques are that we're working with, right? How to figure out what this problem is, why this stupid Western blot won't work, right? Just like the cave explorer who, eventually will set out candles around the cavern and illuminate this one piece of the cave, this explorer doesn't stay there. They find the dampest, darkest corner of the cave that might lead to another cavern, right? And so as scientists, we spend all our time in the dark chasing after new places of darkness where we don't know the surroundings. And so when it comes to presenting our science then, our job is to take our audience on this journey, right? We want to help the audience follow along, not just with all of the victories, not just, you know, show them the cave with all the lights on, but to be able to explain the struggles that got us there and the payoff, right? If we had victories in the lab every day, those victories would become mundane. But they're so amazing in part because they're rare. Now, the good news is you don't have to be a novelist to be able to present your data in a way that takes your audience on a journey. But I do think it does take work. And so today I want to talk a little bit about some of the work that it takes to bring your audience along with you when you give a talk on scientific data. Okay, so here's a summary of what we're going to talk about. I want to talk about telling a story, and I think this is really important. I'll tell you what I mean by that. I think less is more. This is an important principle that you need to think through in a number of different ways as you present data. But at the same time, show the data. Okay, I'm going to tell you exactly what I mean by show the data. And then the last point is practice, practice, practice. And this is what's going to make it easy to be able to do the above. Okay, so first let's talk about mistakes. You know, none of us want to be like Professor Leibovitz here, who forgot his duck. But we all make mistakes. And so I want to try to, as awkward as it is to do these presentations over Zoom, I want to try to make this a little bit interactive. So we're going to take just a minute, and I want you to write in the chat box do we have access to the chat box with the screen shared?
Yes.
That we do. Okay. So I'd like you to just jot down some of the mistakes that you have seen in people who give scientific talks, and you know, so just jot down one or two common mistakes that you see in how people give talks. Yeah, I'll read some of these. We have PowerPoint karaoke, and we have wordy slides, bad choice in color schemes, miswording, not giving adequate background, blurred images, going into really specific genes or terminology that the audience isn't familiar with, not enough background, yeah, excellent, typos, talking very fast, maybe that's directed at me. Yeah, taking publication figures and not formatting them, timing animations badly, too many figures, poor organization, not enough images, lots and lots of data, assuming that the audience knows everything. These are fantastic. Okay, so I've written down my 3 biggest pet peeves. So I had this Twitter thread a little while back where I described a taxonomy of academic talks, and some of these are taken from that. So the first one is, I know I'm out of time, but I don't respect you, right? So, I mean, how many times have you been in a class or a presentation where the speaker they know they're 10 minutes over, and they'll even say, oh, I'm sorry, I know I'm out of time, but I just want to show you this one more thing, right? And what it communicates is not, I'm amazing and look at all of the things that I've done. What it communicates is, I don't respect you, right? So this is my biggest pet peeve. People who go over, hopefully I don't go over, are really frustrating. Okay, so then there's the I did a lot of stuff. We have this desire to impress people when we give presentations, right? But sometimes that turns into pouring all of the data, every last little experiment you did into a presentation. And the message that your audience comes away with is simply, they did a lot of stuff. I have no idea what they did, but it looks like they did a lot of stuff, right? And that is not an effective, impactful presentation. So avoid the I did a lot of stuff error. This is one that lots of you guys picked up on, the wall of text, right? So I have a little rule of thumb that I try to stick to. I don't like to go above 8 lines of text on a slide. If I'm doing bullet points, I try to stick to just a few. Keep to 1 idea per slide. We'll talk about that. Sometimes you can go to 12, right? Like that quote I gave you earlier had 10 or 11 lines in it. But when I do that, I try to read them out exactly, because I'm putting this information in there because I want everyone to hear it exactly as it's written, right? Otherwise, summarize. Remember, your slides are for your audience. They're not for you. Okay, so we'll talk about that. Now, but before we talk about how to present in terms of putting together a presentation, I want to talk about presenting data, because one of the exercises that we're going to be doing today is thinking about taking raw data and turning it into something that we can present. So there's this quote from this guy, Edward Tufte, who's written a number of books on data visualization. This one, The Visual Display of Quantitative Information, I think is really excellent. And this quote comes from that book. He says, above all else, show the data. So what do I mean by show the data? Well, the first thing is eliminate what I call chart junk. Okay, what is chart junk? Well, there's information in your data, right? Things like the size of the bar, which tells you how much of whatever quantity it was. There's the information on the y-axis. There's the different groups that you have involved here, right? But then there's all of this other stuff, this chart junk that doesn't provide any additional information. It's just ink on the page. So the pseudo 3D thing, I hate that so much. The weird shaded backgrounds, cross hatches, etc. You want to try to limit the amount of non-information on your graphs, right? This will actually make it easier for your reader or for your audience to understand what you're trying to say. Okay, so what do we mean by show the data, and why do we want to show the data? So I want to show you these 4 data sets that come from this guy Anscombe back in the 70s, and he put these 4 data sets together that have the same summary statistics. So they have the same mean of the x's, and if you just take the mean of all these numbers and the x, it's the same mean of the y's, the same linear regression line, the same r squared for these regressions, and the same standard error of the slope. Now, looking at this data, we can tell right away, these data sets are not identical, right? But all of the summary statistics that we often report are the same. So it's really critical that we actually show the data rather than just showing summary statistics. Now, how do we do that? Here's a kind of plot that you'll often see in scientific papers. I and lots of others like to call these dynamite plots. And what do we do with dynamite plots, right? This is a bar where the height of the bar represents the mean of the group, and then the error bars, these little whiskers, tell you what the variability in the group is, or standard deviation or standard error of the mean. And what we want to do with the dynamite plot is to blow it up. Now, here are 4 different groups, similar to Anscombe's quartet, 4 different data sets that give exactly the same graphs when presented as dynamite plots, right? So we can have data that's symmetric. This is nicely distributed data. Both groups are similar in distribution. We can have ones where there's outliers. We can have ones where there's a bimodal distribution, or data sets where there's different numbers of samples in different groups. And each of these differences can influence how we interpret the data, right? So if you're just going to show this, you're losing a huge amount of information, both for your reader and for you as the scientist trying to interpret it. So my encouragement is to blow this up. There's a citation down here. Let me see. Yeah, this citation from Tracy Weisgerber, and this paper is really excellent. I would really encourage you all to take a look at it. And she goes through a number of different ways that you can present your data that gets rid of this dynamite plot, and how do you show the actual data points. Whatever you choose to do, the most important thing in my mind is to show the actual data points, right? So you can put these on top of a box plot, or you can put it on top of a bar plot, or you can put it just with a line and a whisker for the standard deviation, et cetera. But the most important thing is that you show the data. Okay, I want to end the data discussion with this little example that's called the Datasaurus dozen. This is similar to Anscombe's quartet, right? All of these different distributions of data have all of the same summary statistics, including regression analysis. But we can see these all in different ways, right? From stars to lines to dinosaurs. And so we want to think through, how do I present the real data, not just the summary statistics? Okay, now let's talk about giving talks. Why do we give a talk? Why don't we just email one another our latest paper and let everybody read it on their own time, right? I mentioned this earlier. The temptation is, when you're a presenter, to make the audience think that you're really smart, right? And when you come into a presentation, you have motivations for why you're doing the presentation, and the audience has motivations for why they're there. Oftentimes, because we're people, our motivation for giving a talk is to show that we're really smart and we have our stuff together. So the goal is convince your audience that you're smart. But maybe a better approach is to make your audience feel like they're smart, right? And this is, if you change your perspective on what is it you're trying to do when you give a talk, it will dramatically influence the way that your audience interacts with it, right? So why do we give talks? We give talks because people are relational. And I always get more out of a story, out of a paper, or say a set of data, when I hear the person who did the work tell me the story of the paper, rather than sitting down and reading the paper. It's important to read papers, and papers are going to be thorough and complete and detailed, right? But it's always better to be able to hear the talk. And the reason is, and the way that we accomplish this is by telling a story. So Robert McKee was this screenwriter he now gives seminars on how to tell stories for screenwriters and artists. And he said the stories are how we remember. We tend to forget bullet points. And so when you give a talk, you're going to have slides, and those slides are going to have bullet points on them, right? But people are not going to remember the bullet points. What they're going to remember is the story that you tell with your data. Okay, so how do we tell a story? The first thing is to set the stage. This, I think, is really, really, really important. It's our job to get the audience on your side, right? As you guys saw at the beginning of my talk, I really like to pick a person or a story that doesn't really have anything to do with my science, and integrate it together. But you should be yourself, right? Do something that you feel comfortable with. I absolutely would not have been comfortable doing that when I was first starting out in science, right? So what you can do is you can set the stage, sort of build the drama of where the scientific field is, and you want to point people. I think of it like like a funnel, right? You want to funnel people to the gap that you're going to fill. My favorite way to present, as I mentioned earlier, is to talk about the failures and dead ends, right? We call these negative data, but sometimes these are the things that make the story compelling, right? If there's no conflict, and your story is all rainbows and butterflies, it's not so interesting. So I really like to tell the story when I give presentations on my science. I really like to tell the negative results. We tried this. We really thought this was going to be the thing, and it turns out it's not, right? Use repetition and growth to help your audience follow along with you. So sometimes there's various ways to do this. You can use a repeating model that grows with the data, right? If you're studying some pathway and you're with each experiment that you do, you add to that model, it can be really helpful to keep your audience following along. And then you want to end with a payoff. You want to go back to the gap that you set up at the beginning and show how you've filled that gap. So when it comes to building your narrative, you're going to do this with the results, right? Your data is the way that you build the narrative. And I like to say it like this: you really love your data, right? You spend a lot of time gathering that data, but love your audience more. What I mean by that is, don't overwhelm them with data. Don't just dump your data on top of your audience and let them try to sort it out. You know, if I'm building a barn, I don't want somebody to hand me 10 beams at once and not tell me where to put them, right? So limit one idea per slide, just a single thing, and then explain everything that you show. If you're going to show it, you want to explain it. And finally, you want to practice, right? This first one is something that I really struggled with at the beginning of my career. There's this desire, and I still have it, this desire to say, I'm really nervous about giving this talk. I'm not sure how this is going to go. I've never given this talk before. I'm concerned about whether I can do this over Zoom. But when you call attention to your shortcomings, or what you perceive as your shortcomings, people are there because they want to hear you, right? They want to hear your take on your data. And so by drawing their attention away from that, you actually lose impact. I really don't love it when people read their comments, right? So the best way to do this is to practice, right? Get used to talking about what you're gonna say. I always prefer when speakers look at the audience. This is really complicated over Zoom, right? And we can talk in the discussion later about like what are some ways that we can try to do Zoom talks in a better way. But look at your audience. It really matters. And then to just stop it already with the laser pointer. I think most talks would be better if we just didn't have laser pointers. I'm really bad at it. My hands tend to shake, and it just is distracting. So I think it's better generally to animate your slides in a judicious way and help people as you design your talk, rather than just wave the laser pointer at them. Okay, so in summary, when you present data, tell it as a story. This is the way that people internalize information and remember it. Less is more. Show the data and practice, practice, practice. And when I want to add this one to the beginning. When we talk about doing an introduction, I always just memorize word for word the first 2 slides of what I'm going to say. Right? Sometimes I won't memorize everything, but I always sit down and memorize those first 2 slides, because that gets you moving. That gets you into your presentation. That's always when the butterflies come out. So practice, practice, practice. Okay, so that's all I had to say, but I'd love to have a discussion about some of these ideas. If you're interested, this is a little bit of a shameless plug. I'm giving a talk on Friday in this e-talk session that's organized by Ankur Singh and Greg Hudala. And I'm doing something a little bit different. I'm doing this thing that I call a choose your own adventure talk, where I have the audience pick what we talk about. I don't know if any of you have read these choose your own adventure books. But if you want to come and participate, it would be fun, because I don't want to give a talk where I ask people to participate and nobody shows up. Okay, so I'll end there, and would love to have a conversation on this.
Thanks so much, Joel. This was fantastic. I really enjoyed it. Well, I think we have a couple minutes if there are questions. So if people just want to unmute themselves and ask a question, there's time now. I also want to say that Joel will be around during the whole workshop. So please ask questions if you don't feel comfortable asking them right now. Natasha?
I mean, yeah, I'd like to invite any of the bootcamp participants or anybody to ask questions first, but I have a question to start off. Okay.
Sure.
Okay, so the question I have is, well, when we're starting off as PhD students, we don't have like any data typically. Maybe we have like one little experiment we were able to do. So like, what kind of advice do you have for us that are trying to tell a story, but we don't have much of an ending?
Yeah, yeah, absolutely. So my favorite talk that I have ever seen, it was this guy, Chris Hernandez, he's a professor at Cornell. He gave a talk at a Gordon Research Conference, and his talk had one slide of data. It was one graph, and the rest of the talk was setting up this graph, explaining how it worked, and then giving us an implication, right? So you don't have to have a lot of data to tell a compelling story, right? There's a reason that you're doing this work. There's a gap that you're trying to fill. And if you can clearly say, look, here is my field, and here's this gap. And if we fill this gap, it's going to have an impact on the field. Take the time to set that up. I remember when I was a student, I wanted to kind of get to my data as quickly as possible because that's where the part that I thought was exciting. And I thought that everybody else would be bored with my introduction. And now I think I have more fun giving introductions than I do talking about the data, because I really think that the setup is important. So just because you have one graph doesn't mean you can't give a super compelling talk.
I have a question regarding, you mentioned talking about failures and dead ends. Usually there's like a lot of failures and dead ends. So what is the right amount?
Yeah.
Or which do you choose? Or
Good question. So in the same way, like, I have this principle that less is more, right? And in the same way that when you finish publishing a paper, you've got a lot of data, and you could try to show all of that data, but people would be overwhelmed by it and they would be lost in the details, right? So what you want to do is pick the really important pieces of data that really show the pieces of your story. And that's where I think you can use this negative data. When you get to a point where you say, all right, I got to this question, and it could either be explained by this thing or this thing, right? And so we put a whole bunch of effort into this hypothesis, and it turns out we were totally wrong, right? And then you pivot and show the real answer. That's super compelling, right? If you just show negative data for the sake of showing that you did a bunch of stuff, you tried a bunch of things, it works about as well as showing that you did a bunch of things that worked, right? People are like, they did a bunch of things. And that's the end, right? So think about telling a story with your data, setting up a question. Turns out this is wrong, but we figured it out. It's actually this thing,